Good morning everyone, welcome back to our last and final video for Orbital Milestone 3. I'm Chee and my partner here is Meng. Today we'll be covering all the bits and pieces of our Orbital project, Hack and Steep.
We will be covering the progress every milestone, the setbacks every milestone, our ambitions and reasons why we chose to take on this project. Starting off with reasons why we chose this project. Being avid gamers that have invested countless hours in gaming, we thought that this would be the best opportunity to experiment and learn a thing or two about game development. Who knows, maybe this exposure might lead to a lifetime decision.
With some of our favourite games being Hades, The Binding of Isaac, Enter the Gungeon, and Dead Cells. We decided to take on the challenge of making a top-down roguelike shooter or hack and slash with a pixel art style.
Initially, our story follows our protagonists on their battle for the last seat at the library, battling through hordes of other students to gain that last seat, with these students getting more and more agitated as finals loom over their heads.
We also aim for 3 main levels with bosses and mini-bosses. Additionally, we also desired to implement a reward system based on the concept of welfare packs, and a shop system based on the cool sports shop that we have in Com3. Spoiler alert, but we were dreaming way too far for how little experience we had in game development. They say if you aim for the sky, you hit the stars or something, so hopefully our final product is somewhat of a low glowing star.
With high spirits and an abundance of drive and hope, we embarked on Milestone 1. In Milestone 1, we spent countless of days learning Godot, a game engine that neither of us have touched or even heard of before taking on this project. We went through loads and loads of videos and documentations, trying our best to internalize the information and all.
With our newly developed skills, we implemented the finite state machine and procedural generation. The main focus of the development of the player character this milestone is the implementation of the finite state machine. The FSM allows the character and subsequently added enemies to perform a series of actions, managing its behavior with other game systems and animations. It also allows us to add new gameplay systems without having to overhaul the entire code.
As for the procedural generation, it seems that games such as Enter the Gungeon have a set of flowcharts that governs the structures of the dungeons. We feel that such flowcharts are indeed very useful and are considering implementing them into our algorithm. They will act as a set of rules or restrictions that give us more control over the pacing of the game. So, how the algorithm works in Milestone 1 is as follows. 1. Create X number of rooms of random sizes at the origin. 2. Separate all of them using the physics engine which pushes the rooms apart. 3. Cull a part of the room, creating more space between rooms. 4. Create a minimum spanning tree between all the rooms. 5. Add hallways between different rooms to connect them.
Despite facing some challenges along the way, our spirit could not be shaken and we were ready to take on Milestone 2. In Milestone 2, it involved a lot of heavy work on our code and assets where we pumped out a working player character, simple enemies and a somewhat working dungeon generation.
The biggest addition we have made to our player character in Milestone 2 is the completely original animations and sprites. We have decided that it would make the most sense for our player character to face the mouse cursor. I mean, it's best to look at where you are attacking, right?
We chose to do this in 6 directions, which means that we needed 4 separate sprite sheets for north, northeast, south and southeast directions. Northwest and southwest directions are just achieved by flipping the corresponding eastern counterpart.
Another big change can be found in our dungeon generation. Our original approach in Milestone 1 was promising and theoretically appealing. However, the nature of Godot engine and our inability to debug better and fix major problems in the algorithm made this an insurmountable mountain that we cannot climb now. So, after many hours of struggles, we decided to put down this beautiful theoretical horse and try a different, more achievable approach which might be better for our idea and design of the dungeon.
Our new approach follows a variant of the random walker algorithm. It allows a good blend of simplicity and control, perfectly suiting our game needs and skill level. Additionally, it allowed for weighted probabilities, which allowed us to favor more preferable layouts that serve gameplay experience. As you can see in the demo, with each restart, the layout of the dungeon is different. Beyond that, we have also decluttered and reworked our FSM to be more modular and expandable. Though it did take quite some time, and will likely not be a net benefit for our efficiency given the short runway to its submissions, we believe that's the right thing to do in the spirit of good and clean code that we have always tried to achieve.
Enemies have also been added with basic pathfinding algorithms, and we have also added many more custom assets that have all been hand-drawn by us.
After being destroyed by bugs and our inabilities to execute certain ideas, we still put on a strong front and were determined to put out what we set out to do. In Milestone 3, we had the biggest changes to our game. With the final deadline looming close, we knew that we had to try our best to finish as many features as we set out to do. Firstly, we added hurtbox and hitbox components, where hurtboxes will get hurt and hitboxes will hit, meaning that the hurtboxes will take damage while hitboxes deal damage. This way of implementation separates what would be one collision shape into 2 components, offering modularity, flexibility, and a better control over entities.
We also added a health component which basically controls how much health an entity has, and takes care of anything health related. This makes use of composition instead of inheritance, which would be a lot more useful and effective if we had lots of entities.
So after trying the game out, the enemies were boring and honestly the pathfinding kinda sucks. As such, we decided to implement a smarter pathfinding algorithm which makes use of different vector arrays and vector properties. Simply put, we get the simplest path from the enemy at hand to the player, then we take the vector of the next position and calculate its dot product with 8 different equally spaced out directions from its interest array, where the higher the value, the more the interested enemy is in taking this direction.
We also added raycasts in those directions that can detect collisions with the row and other enemies. This allows us to create an obstacle array, where if there is an obstacle in the direction, the value will be set high and the neighboring directions will be padded down such that the enemy will be less inclined to go towards the obstacles. Finally, we sum them up and pick the highest interest vector, which would be the most optimal direction.
Moving on, we also introduced many new states, such as the hurt state, the dash state, and the dead state. In the hurt state, entities take damage and are immune and stunned for a duration of time. In the dash state, the player becomes immune and moves a certain distance in the direction that they were dashing. And in the dead state, the entity dies.
With this being the final milestone, we added many new assets and revamped old ones too. Doors were revamped, rooms were redrawn, and new designs were added. More player and enemy sprites were created for animations and all. We even added a mini-map such that players would know where to travel to and have a better grasp of where they are on the map.
We also attempted to complete the stage 2 of our procedural generation, which is cycle building. However, after spending many days trying to come up with a certain algorithm and debugging many problems, the best we could do was just to prevent collisions. With the deadline coming too close for comfort, we decided that we had to cut this feature and make the best of what we already have.
As such, we removed Cool Spot, welfare packs, the cycle element of procedural generation, and bosses. Instead, we focused more on the user interface, fixing existing bugs, and making the best of what we already have. We added a defeat and victory screen. We added lighting to the game to make it more scenic and atmospheric.
Lastly, we added audio to the game and fixed the final bugs. In the end, our game is a simple top-down roguelike hack and slash with a singular level with enemies and melee weapons. So last but not least, please enjoy our final game demo.
Ah.